there. Hello, so welcome to this 347, and I'm the instructor, Monica Hu, and I teach in the Mathematics and Statistics Department at Vassar College. And I know many of you took classes with me or from other occasions at Vassar, but I think all of the non-Vassar students are new to me and I'm new to you. And hopefully we all get to know each other more. I mean, not only between the instructor and the students, but between students and also between students from different schools and all that. So I'll explain that a little bit more about the course sharing project and why this course is part of it and how it runs. But I guess it does give the flexibility for our Vassar students. If anything comes up, you have to be absent from a course, from one lecture. You can watch the video because we're going to record everything anyway. And you can also join remotely if for some reason you cannot attend class in person. So with that in mind, I'm going to try to share my screen and get started. And just so you know, I will use the iPad to join so I can annotate and all that. But we will also do some coding demo in class. So when that happens, I will use my computer instead. Okay, so should everyone able to see the screen share? I'm trying to see some nodding maybe from any of you. Okay, sounds good. Thank you so much. All right, so we'll get started. So today on Friday will be fully virtually for everyone, and I will post the slides and all of the markdown and everything to Moodle after today's lecture. But in the future, usually I will just post the slides beforehand, just trying to make some final changes and all that until now. And so yeah, for today on Friday, I think it's the introduction. It's going to be introduction about the course. About the course sharing project and all that. And also we will do some review of probability, mostly probability, but every now and then you will see that we get to review a little bit calculus and linear algebra along the way as well. But I will try to provide as comprehensive as I can have at the beginning for the review. Like I said, so we're going to have the course orientation, and then the last three topics will be also some introduction about probability and Bayes rule, and then a toy example of Bayesian inference in general, and then lastly, the probability review, which I would imagine would take today and Friday's time. All right, so for the course itself, so like I said, that's my email address. I think I already sent email to everybody, so you will have access to that. My office is in Rocky 403. And our class, when we meet in person starting from next week, is going to be Old Laundry Building 105. We use that room because they have a ceiling mic from the top, and that will be able to record the audio much better than in a regular Rocky classroom, and that's the reason. But overall, it's a pretty compact classroom, so hopefully we'll all be able to. I sent an email the other day to everybody and to Vassar students. I took a photo of how you can most efficiently go to that room 105 from a particular door of Old Laundry Building. So make sure you use that next week. And we also have labs, as you will see in class, and then I will just use some of the lectures. We won't have separate lab time, but this in-class lab will be able to give you the hands-on experience and also Q&A questions and all that. Office hours, I put them on Moodle as well as in the syllabus as well. I have an hour and a half on Tuesday, an hour and a half on Thursday. Both of them are on Zoom. And on Friday afternoon, an hour-ish after our class, I'll be in person in my office for an hour. But you can always schedule an appointment if none of this works for you or only just for a week or something. And the links are on Moodle as well, which is the same of today's link. All right, so the prerequisites, this again, I'm sure we all know it and have it, but just to reiterate, you should have taken multivariable calculus, linear algebra, and some version of introduction to statistics. So maybe 240 and 141 at Vassar or AP statistics, or the other courses you have at your own institution, and also a version of probability at Vassar is 241. The textbook has a free online version, which you will find the link in the syllabus as well. It's called Probability and Bayesian Modeling. So we'll use the second half of the book throughout the semester for most of the part to cover the important concepts of Bayesian inference. The software we're going to use is going to be R and R Studio. I think everybody has experience with it, but if not, let me know how to install, download and install. The links are here. You should choose the right OS for your own computer and all that for the process. And I'll also mention later for the second half, we're going to use a particular software within R that is to do Bayesian Markov chain multi-color estimation. So I will give instruction when we come to that part. Usually the installation, everything should be pretty smooth given my experience. The web page, the main one is Vassar's Moodle. And so you, I think once, for the non-Vassar students, once you have access, you will see the whole structure. But overall, we have different chunks of different topics and all that. And within each, you will see homework, readings, and labs, instructions, and everything. Also, I share with you all the tentative schedule on a Google Doc. So please check that often for any updates. Usually I update that regularly to see what we're going to cover for next lecture, for example. And it also has instruction about the sections of the textbook where you should read, and then any due homework, like the lab or homework or project proposal, things like that. So that will be the main. So anyway, everything comes from the Moodle page. So if you go to Moodle, you should find everything that you need. All right, now is the fun part. The class is divided into three general parts. We're gonna talk about foundations of Bayesian inference. That includes Bayes' theorem, conjugate prior posterior distribution, predictive distribution, etc. Those will mainly covered by the first two topics of our course, which is according to I will just use prop Bayes to reference our textbook name, Probability and Bayesian Inference, chapter 7 and 8. Those are what we call trying to do Bayesian inference for a proportion, like a success probability, and also a Bayesian inference for a mean, like the average income, something like that. So we will cover the foundations of Bayesian inference in those contexts. But specifically, the topics that I listed over here will be the core concepts that we need to learn and also get a good foundation of. And then the middle part-ish will be what we call Bayesian computing. So you will see that we're going to motivate by doing multi-color approximation, which I think some of you probably have done it in the past already. And then that's non-Bayesian, particularly. It's actually utilized in many other statistical context. But then we motivate using that, and then we're going to introduce the main computing technique in Bayesian inference is called what we call Markov chain multicolor. So part of it is multicolor, as you can see. Another part is Markov chain. So we're going to motivate why that is and how that works. In particular, we're going to cover two MCMC. So we use MCMC as short for Markov chain multicolor. We're going to cover two important algorithms, the Gibbs sampler and also the Metropolis-Hastings algorithm. So both are important and useful to do MCMC estimation. And also we're going to cover some diagnostics of how to make sure that MCMC has run well. Those will mostly be coming from the textbook chapter 9 as well. Also, like I said, we're gonna, when the time comes, I'm gonna introduce this JAGS. It's a software, but then we're gonna use a particular package in R to run the software to implement MCMC algorithm instead of writing up, the step-by-step by yourself. So all of this are mainly coming from chapter 9 of the textbook, but the computing part is actually interwoven with all of the different concepts throughout the course as well. But I put a separate section just here so you know that computing is important and component of doing any Bayesian inference, maybe more so than many other. Well, machine learning, I'm sure you have to do a lot over there as well, but comparing to like a statistical inference or mathematical statistics course, you will see more, I think, of computing, and in particular, use R in our course to realize all of the model estimation. And then towards the end, we're going to cover different modeling techniques, for example, Bayesian hierarchical modeling and Bayesian linear regression. And I'll also introduce some advanced concepts like latent class modeling, etc. So those will be coming from mostly from chapters 11, 12, and 13. What I want to mention is that there's no strict boundaries between these topics or like the divided parts, because they really heavily depend on each other. I try to put them into this order just to give you a sense of what we're going to encounter. But you will see that as soon as we start to do computing, we also have modeling and applications in mind to motivate us how to make things work and all that. So they're all really interwoven in my mind, but I'm sure that you will get to see them as well as we go along. And a couple of slides on this course sharing. So this is part of the, I should update it, it's 11 schools now. It's called the Liberals Collaborative for Digital Innovation, LICO, and we are under the course share project. The goal was to, and it is still to, enrich upper level math and stats offering across the 11 different schools. I think the project started in the academic year of 2016 and 17. And I have been sharing our course for a few years by now, so I just list whatever the numbers if you're curious, but mostly from Swarthmore, Amherst, Carleton, and this time around Washington Lee University as well. So because of that, we will have lectures synchronized online in real time. So you will see that for Vassar students, once we start to meet in person next week, I will just have my iPad and whatever in front of that classroom, and then everything will work smoothly overall, given my experience. So I will have the iPad join the class, and then the Vassar students, you will all see the front screen, just like what we're going to see right now. And but I will get to see you at least in person, and I will do more in-class work like that. And because of that, I will record all of the lectures for remote students. But of course, every Vassar student, if you need to, feel free to join remotely if you need to. And for us, because of the large class size from different schools, I will try to encourage and enforce, if I can, group work across different campuses, meaning that the teams of the labs and all that, and case studies and some participation, I will assign teams of students from different campuses. And now we all very good at remote working anyway, so I'm sure everybody can figure out the logistics and then just make it work. Okay. So I will, like I said, I already sent a couple of surveys. One of them is a pre-course survey. It's about the online hybrid teaching and learning, and there will be a post-survey, a post-course survey as well. So my experience so far, and I think because of the pandemic and everything, also even reinforce some of the ideas. Some of the learning material are really suitable for video form. So you will see that we will have a guest lecture from one professor from the Cog-Sci department or cognitive science program at Vassar, who does extensively Bayesian hierarchical modeling for his research. So he, well, we recorded a lecture already, so you will see an introduction lecture from him of the Bayesian hierarchical modeling approach for cognitive science models and applications. I will also try to do some recaps if there are recurring questions through office hours, and our demo will be really good as well to make it in a short video form. So I will try to include that as much as we can. And you will see that because of the online hybrid sharing model, we're going to use Moodle extensively, the Moodle discussion forum. I found it really useful to foster learning community and ask you to post a self-introduction and all that. So we'll do a lot more throughout the semester. And like I said, I wish I had to have more interaction among Vassar students and remote students for case studies and projects. And that's one of the reasons why we do the self-introduction at the beginning, so you can share some of your interests, and feel free to reach out to others who you find common interests that you might be want to work on the projects together. And also starting from next week, when we meet in person at Vassar, you can try to sit with a different neighbor so you can have more in-class activity and interaction with your own peer students at Vassar as well. And because I do this pre-course survey, post-course surveys, I did get some anonymous feedback and advice for students and me as well. So for example, some of the useful thing I would like to share is the previous students' advice and comments for anybody who is going to take this course. I won't read them out loud. Like I said, I will post them on Moodle afterward, and also through email for those for remote students who don't have access to Moodle yet. But nevertheless, those are, I think, useful advice. For example, you should try to work on each homework in a small portion at a time so you don't get overwhelmed in the end. And also some of you, which I will share on the next slide as well, is that because the videos, lecture video is going to be posted, and even you attended a real-time lecture, you might rewatch some of the material just to catch up and answer a question. So that will be really useful. And then of course, go to office hours and get an early start on the project and all that. And I will have a timeline for all of the projects. So you will get a proposal due around the midterm-ish time. And then we'll also have feedback along the way. So hopefully, but nevertheless, I think the earlier you start thinking about and finding a team member, if you want to do a team project, the better I think you'll be prepared. This whole slide, of course, I won't read it, but I just want to show you that the responses to the post survey. Do you rewatch the lecture recordings? How often and for what reasons? I have remote and master students notes, all anonymous, but I did collect that information. So feel free to read them over later. And of course, use the recorded videos as you see fit. All right, like I said, we have 3 parts of the material, foundations, computing and modeling, and then of course the review of material, which I will do now, today and Friday, but as long as throughout the semester, so for some of the hidden parts. And each part, like foundation, computing and modeling, is a combination of a selection of readings, lectures, labs, homework, discussions, both in class and online on Moodle, case study and project. And then I want to talk about the project a little bit and show you some examples that you might want to check out as well. So course project, you can do it individual or in pair. I will highly encourage cross-campus collaboration, and it's a final product involving the 3 different parts that we talked about. And the project itself, mostly, I think most of you in the past will apply the Bayesian methods you have learned in this course. But occasionally, some people will explore new Bayesian methods to solve research questions of their own choice. That include possibly reading an academic journal and a journal article and try to understand it and replicate some of the results, or even apply the method to a research question with the data set that you have. So we'll see how things go. I try to provide as much guidance as I can and also feedback. So we'll do that once I post the instruction. For the project itself, every team will present at a poster session, which is with the last class. And because of the remote modality from non-VASU students, each team will upload a 2-minute intro video on Moodle once it's ready. And then for remote students who will not be able to present like in person of the post session, you will also record a longer video for others to watch your project. Okay, so with that in mind, I know I've been talking for a long time, so let me show you some examples of projects. Like I said, I encourage everybody to start thinking about projects as early as you can, because that is an important learning outcome, as well as a good way to synthesize all the stuff that we will be learning throughout the course. So all of the links, once I post on Moodle, they're clickable, but for our purpose, let me actually stop share on my iPad and sharing my screen really quick. So I'll be able to show you some of the short videos that people made before as introduction to their projects. And then that will serve also good way to show you what the expectation is in the end. So let me find this one first. Okay. So this one is called Prevailing Wages Across Occupations, a Hierarchical Approach. So let me share my other screen here. And I'm gonna.
This is a hierarchical model to study.
Can I ask, did everybody hear the audio just now? Okay, thank you.
The prevailing wages across occupations, focusing on H-1B workers. The H-1B is an employment-based non-immigrant visa category for temporary foreign workers in the United States. Employers have to file the labor condition application for approval to get H-1B for their employees. The aim of H-1B program is to allow U.S. employers to bridge a labor gap, but at the same time ensure that jobs are not permanently shifted from U.S. workers to foreign workers. However, some people argue that employers pay H-1B workers less than their U.S. counterparts. It allows employers to import cheaper foreign laborers, which causes an outsourcing abuse. U.S. workers therefore have no incentive to move into the field and fill the labor gap. Jobs are permanently shifted from U.S. workers. Therefore, my project wants to investigate the prevailing wages across occupations in the LCA approval using a hierarchical model. From the posterior distribution generated by the hierarchical model, I will also perform a Bayesian prediction to find out if there is a wage gap between national wage level and wages for H-1B workers. It can give us some future policy implications. Few literatures use Bayesian approach to analyze H-1B data. Most of them are theoretical, claiming that there are differences in wages of H-1B workers and natives. They also propose that there is an outsourcing problem. In my study, I will use two data sets. The first one is H-1B application data of 2016 from the Office of Foreign Labor Certification. The second one is the employment and wage data by occupations based on the Occupational Employment Statistics Survey.
My project was about the right.
Add you, I guess, one by one. All right, so that's one. And just an introduction of the full project. And the next one I want to show is called Bayesian analysis of portfolio betas. This is actually a cross-campus.
Hi, my name is.
Sorry. This is actually a cross-campus collaboration between a bachelor student and a Swarthmore student that semester.
It's Julie.
My name is Jorge, and I'm from Swarthmore.
Today, we're going to present the Bayesian analysis of portfolio betas.
So first, Julie will present the widely used CAPA model used in finance to determine stock risk. Then we will talk about how to interpret and how to calculate beta. And we're going to do a calculation of beta based on industries using Bayesian linear regression. And we're going to calculate that using JAGs, and we're going to present some results.
So I'm going to introduce the CAPA model widely used in finance. It is short for the capital asset pricing model. It is a model that estimates the return of an asset based on the return of the market and the asset's linear relationship to the return of the market. So we are thinking of using Bayesian linear regression by using the following formula, where the expected return of a particular investment is equal to the risk-free interest rate plus the beta of the stock times the expected return of the market minus the risk-free interest rate. Here, we use expected return of an investment to be our yi for the linear regression model, and the ERM minus RF would be our xi, and beta I here would be the coefficient that we try to monitor using the Bayesian method. Note here that we don't really have data for the expected returns for investment or market. That's why we use historical returns to as a proxy for the expected returns.
So the way to think about beta is that it's a measure of risk for a stock. If beta were equal to 1, that would imply that the stock's performance is strongly correlated with the market's performance with similar variability. Now, if beta were greater than 1, that would imply the stock's price is more volatile than the market, or the asset's price is more volatile than the market. One common example is the real estate market, which can be very volatile, as we saw in 2008, or just throughout the year, it varies more than the market. Now, if beta were between 0 and 1, that would imply the stock is less volatile than the market, and this category usually includes things like utilities, like electric utilities. If beta were equal to 0, that would imply that the stock is risk-free. And if beta is less than 0, although it's not observed in practice, it would imply that the stock is inversely correlated with the market.
Hi, everyone.
All right, so that's the second one. And the third one is what we call the determinants of health care coverage for children in the US. And you'll see this one is actually a nice comparison between a Bayesian logistic regression and a regular logistic regression. Maybe some of you know. So I'm going to show the link now. And here you go.
For my project, I was interested in the determinants of healthcare coverage for children in the United States, and more specifically, how household characteristics could predict whether or not a child has healthcare coverage. I wanted to tie this into this larger literature on bargaining power and household decision-making. So I looked at relative income defined as mother's income over mother's income plus father's income as kind of a measure of a woman's bargaining power in household to see how that could affect whether or not the children had healthcare coverage. And so I used what's called the American Community Survey, or ACS, as my data data set from 2017. It's cross-sectional and representative of the entire United States. So kind of looking at this binary outcome of whether or not a child has healthcare coverage, modeling it in a frequentist sense, you don't say that just the probability of healthcare coverage is a function of all your indicator variables, but rather you look at the log odds or the logit of P, because this is a continuous function and you say that that is a function of all of your different predictor variables. So extending this to the Bayesian logistic regression is really similar to the linear regression, except you can see here, instead of saying that our data is normally distributed, it's now Bernoulli distributed as it's a binary outcome variable. And as I was saying earlier, instead of saying that P is a function of our different predictor variables, we say that logit of P or the log odds is a function of our predictor variables. And in running my model, I actually ran into some huge computational constraints. The ACS, even when I looked at individuals under the age of 18, because I wanted to see children, was an enormous data set. So I looked at a random sample of 3,500 observations when I actually ran my model. And so computational constraints were definitely one of my biggest problems, but I was able to still find some interesting results from relative income, showing that children were more likely to be covered in households where the mothers made a larger portion of the income. The largest drawback is I obviously was not able to find a causal relationship. I couldn't say that increasing women's share of total income would improve the chances that a child had healthcare coverage, but it's still consistent with the larger literature that found that increases in women's bargaining power and their spending amount improved their children's outcome more than increases in fathers' bargaining power did. And further studies could look to take advantage of some sort of exogenous shift in relative income in households to prove a truly causal relationship between these two different things.
All right, let me show you one last one. And the link for the full list of projects are on Moodle as well, on the slides as well once I post it. So you will be able to see the ones from that semester. So last one is called a Bayesian hierarchical modeling approach for goals in the Premier League season. So this is a sports related project.
Hi, this is Kevin and Jonathan. The title of our project is a Bayesian hierarchical modeling approach for Premier League game outcomes. So why did we choose the Premier League? Well, the first reason is that the Premier League is the most popular sporting league in the world, and they have some of the most renowned teams such as Manchester United, Liverpool, Arsenal, Chelsea, Manchester City. I'm sure you guys heard of these teams. And the other reason that we're doing this is that millions of fans are obsessed with predicting like what teams will score the most amount of goals or the least amount of goals. And they do this for a myriad of reasons, but some of these reasons include recreational betting, and we thought it'd be interesting if we could predict the outcomes of these games.
So we indicate the number of goals scored by the home team and the away team as YG1 and YG2 respectively. And we assign these to Poisson distributions with theta GJ, G being the Gth game, and J representing which team is home and away, J equals to 1 being the home team, and J equals to 2 being the away team.
So we model theta according to a widely used formula by Carlos and Zofras, and they assume a log linear random effect model. We model the home team's goals with log theta G1, and this is equivalent to the home parameter, which represents the advantage for the team hosting the game and is modeled as a fixed effect. And then it's also, in addition to this, we add on the attacking ability of the home team plus the defensive ability of the away team. And the away team goals are modeled with the log theta G2. And this is equivalent to the attacking ability of the away team plus the defensive abilities of the home team.
So we ran our model on JAGS and used the parameter coefficients to predict individual games.
So this is an example of the predicted outcome of a game versus what happened in real life. And in this example, we have Manchester City, which is the home game, and they're matched up against Chelsea, the away team. In our prediction, our model predicts that the home team, Man City, will score around 2 goals, whereas Chelsea will only score 1 goal. And in reality, the score was 2-0 to Man City. And as I said before, we did this for all 380 games in the Premier League season.
I need to find the best way to learn math and science.
Of course. All right. All right, let me stop here. And okay, yeah, so that's the part. Like I said, we don't have time to explain all of them, of course, but you feel free to check out the link, which is in the slides of all of the project intro and all that. And this is really just to give you a sense of what type of projects people had done before. But you should, and as you can tell, explore the things that interest you the most. And like I said, I highly encourage people to work across different campuses to work on the project. We saw the example earlier, and I'm happy to make the connection and all that. And the most important thing, I guess, is to make a post about yourself on Moodle and then share your interest of project as well. And I will try to put the instruction about the project and then let everybody start pairing up if you want to do it in your team or individually as soon as we start it next week. All right, so like I said, the link, the full list of projects is in the link in the slides as well. The slide will be posted after today's lecture. So I also think this will be a good time to maybe answer some questions if you have any, and also invite you to randomly assign breakout rooms to get to know your peer students a little bit and maybe share some of your interest and thoughts so far. So do we have, let me stop share here. Do we have any questions from the class now, given what I mentioned so far? Anything about maybe the project or other components of the class? Right, it is a large Zoom room, so I'm sure like we may be a little bit shy, but with that in mind, let me pause. I think almost everyone is back, and maybe one more room, and we'll resume. Okay, I think everyone is back. So hopefully you had a good discussion and get to know your peer students in the class, even maybe from a different campus. And in the interest of time, I think I will just continue. But like I said, make sure that you post your self-introduction, and then you can get the project idea and team working that way. I think that will be the most efficient in terms of what we have in terms of structure. And of course, any kind of questions you have, let me know. And you can also post on Moodle. We have discussion forums going on there as well. So in terms of the grading, we have 25% for the homework and labs, 10% for the participation. So that includes Moodle posts that I asked you to do, as well as case studies that we do towards the end of the semester. Those are, as long as you do them, you get the participation grade. We have 2 midterm exams. There are no final exam. Each is 20%, and I will announce the date beforehand. For the exams, we will have a take-home per portion that is focused on using R for the analysis, and then a in-person or written portion that would take place in class. We also have a 25% for the final project, and the grading, other information about the grading, all of them are in the syllabus. So feel free to reach out to me if you have any questions about the grading. So before we start doing some kind of intro to Bayesian analysis, here are the to-do list. Make sure you complete the 2 surveys. One is the class survey. The other one is the pre-course survey on Moodle. All of the links are Moodle, and I also sent them through email the other day. Make a self-introduction post as soon as you can, and make sure that you read and watch the other ones and get in touch with people you think you might want to work with for the final project. The textbook, like I said, is freely online, so feel free to use that one instead of buying a hard copy, and start reading chapter 7, which will be the Bayesian inference for a proportion. That's the first topic that we're gonna start, I think, next week. Also, make sure that you download and install R and R Studio, and we will also implement a weekly check-in for participation as well. And that will just help me make sure that everybody's is on track, and also answer any unanswered questions from a previous week. So that, I think, is the orientation part.